Hello. It is time. My audio got a little weird. I'm just gonna listen back to the stream really quick to make sure. Okay. I'm not that loud. Good. So I remember that I said I was gonna remember what I was gonna do today, which was how to handle the steer reset. Do I want to try that? I think I need to try that. Okay. So essentially, here's the idea. Here's the idea. In here, I'm going to start here. Yeah, I'm going to start here. In the vehicle controller. I'm going to track a right input. Right? I'm going to track a right input. So I guess that means probably down here, I'll put in... Right, I like my stuff at the top. Honestly, I really like the stuff at the top. So, up here, I'm going to have a... Yeah, a float's fine. I'm going to have a float for... I'll just call it right. Start it at 0. Now when I get float right, I'm going to take right, add this right, then I'm passing in that. Okay. So this should now mean that the wheels stay in place when I turn them. And I have to physically place inputs to get them to move around, so I'm just going to really simply try that. Sorry. Wow. All right, what's changed? That's what I expected to see. Okay. That's what I want to test first. I want the wheels to literally keep their position. And I'm going to have the wheeled vehicle controller. I could do this through scripting, or I could do this through... Alright. I know how integrate forces and stuff like that works. Honestly, I think it's kind of slow. I think it's slow to do it that way. Why is it building everything? That sucks. I did update some stuff, so hopefully my camera doesn't freeze today. But I gotta keep a sharp eye on that, honestly. I gotta keep a sharp eye on the camera. Try to watch when it freezes. Let me go ahead and get this open. Okay. It's so slow. I guess I can just keep working on this. I don't know. So I have the controller here. Oh yeah, wait. How would I do this? It would have to be here. This is where the wheels have to reset their input. Jolt vehicle does have the controller. I guess I could call like controller update. I could just say the controller should have vehicle controller has to have like an update method, and I can do whatever I want with that. It does not have access back out to the vehicle. Maybe I will have to put it in code in Godot. Rigid body state change is gonna call a particular method here. Probably here. Integrate forces. There it is. So I can write integrate forces on this because the Jolt vehicle is a rigid body. So I have this. I believe I call body state changed. Right. I do that. So I guess that's where all the input really happens, right? Yeah, okay, so I guess my idea doesn't quite work exactly, and yeah. I mean, All right. I guess it doesn't quite work. I will let this finish building though. And I guess I can write here. So I'm getting something done while that's building. Vehicle, base, wheel jolt vehicle. So I can write an integrate, right? Yeah, jolt vehicle is a rigid body. So I have integrate forces. Should I put that above or below physics? Integrate forces happens before physics, I believe. It's part of physics, right? Now, integrate forces, I forget what it gives me. We get a physics direct body state 3D. I think it's just the exact same name. Void, and I can write pass. Now, I don't think it does anything else. Yeah, this is basically just to apply transformations. And then this contact monitor, that doesn't do anything. So yeah, very simple. So I think in the reset, I think this is correct. I want to reset right, but I would like an added right. Here's what I'll do. I'll have a group specifically for controls. No category. I'll have a Boolean. It'll be enable integrated steering. It sounds like a really cool name. I'll be honest, integrated steering sounds like an awesome name. Is this zoom correct? I feel like the text is kind of small. I guess it is. Is this done? Cool. Alright, let's just go back to Godot for the editing. Essentially, I should be able to read all the wheel transforms at this point. I'll have the steering value operate as an add and subtract to a different value. By having the tires, by having steered wheels. Surfaces. Collisions? I don't know. Steered wheels, I don't know how to describe this. This is really, it's a hard thing to describe. All right. So if that's turned on, I have some of our, not right, but, right integrated value. So when I do steer, I'll just set right. I won't do anything different there. And reset, I don't do anything different there. But down here, or right, let me go to player, I think, and I feel like, okay, the more I'm thinking about it, the more I think this should probably, I don't know, it's weird. There's just some information that I have from the player that I don't have on the vehicle. Alright, I'm making the executive decision here. It needs to work so that I just pass in 1 or -1 or 0 or break or don't break, and that's it. I think it really needs to be set up that way, and no other way. I can still have input acceleration, I guess. Yeah. I'm saying it. All control stuff. Ah, what do I... no. Here's my thought. What if... Alright, let me think about it 2 ways. 1, how would I network this? 2, how would I have like an NPC drive a vehicle? Doubtful that I'm going to have any NPCs driving. Likely I'm going to have networking. So what does the vehicle do? At some point in the vehicle, I have to tell it, I have to do the same stuff. I have to say apply set driver input, right? I got to call this method. What do I call it with? I would call it with received values. If it's networked, I call it with the received values from the network. So I'm not doing any manipulation on this. When it's networked, I'm just taking what the server tells me and I'm applying that. If it's an NPC driving, what am I doing? Like ideally, I just take the input and I apply it. I don't do anything with it besides maybe some debug stuff. But I have this unique case where to make the steering work better for a player on a keyboard, and not even on a keyboard, just even on a controller with sticks, the tires should reset. If I'm not applying input, basically, the tires should reset according to the road, as if I have physically released my hands from the wheel and I'm just letting whatever happen happen. So yes, I think this is just a unique case where I need to do it here. I need some extra stuff here. On the player side, what do I do? Hey, Yulia. Having a fight with a friend about new Pokemon, and I'll send a screenshot on Discord. What your opinion? I don't I don't know about that. I will look though. I don't have opinions about Pokemon. I think it's cool, but I think any of the 3D games are bad. Why is it that's just a screenshot of Sonic? What is that? Looks like the same graphics as the new Pokemon game. That looks better than the Pokemon game. Those are better graphics, actually. I also think I know that game. Isn't that the game where... That's the one with like the popular fan dub, I think? Yeah. Rip. Hey. Yes, the girl kisses him. Yep, that is the one. That's the one then. All right. Okay, so in integrate forces, if I am, I guess I can do this. If enable integrated steering is false, so if not, I'm not doing anything. Why is it upset? State is never used. Oh, okay. Selling a 10 graphical $10 graphical upgrade to achieve a 2006 standard graphics. They are literally better than current 3D Pokemon graphics. I mean, literally whoever is like the visual designer, they need to be fired. They both don't care and they suck. They're bad and they don't care. All right, so if I'm right about this, the right input should be applied at this point. No, it's not, because this happens in physics process, doesn't it? Where does update vehicle happen? Do I call this in... Okay, input, I have said, needs to be processed in... in non-physics. Good, right. So... at the time I'm running this... Right. I was thinking I could probably just update the right value, but I don't think I can do that. I think I need the second value. FPS sucks for opacity materials. You dethrone Power Software for worst code ever? I don't think so. And I have issues rendering alpha channels. Hard coding every glass material. Okay, that's just crazy. Alright, that's all I had to do there. Just set right to right integrated. So, this is after the vehicle is moved. So I think the first thing that I want to do... Alright, let me just do this. Right. I guess I'd actually just say right integrated. The other way around. Right integrated. Do that. And then I'm going to turn this on. All right. So this should now mean when I press left and right, the tires will stay. All right. I didn't expect that. I didn't expect the wheels to like free turn like that. Okay. All right, well that needs to be limited. All right. Yes, it's basically impossible to control, but, you know, it's getting there. So now I want to add my input. I think before I add my inputs, actually, I need to figure out what do I need to figure out? Okay, let me just do this. If right is equal to 0, I'm going to do some stuff. I'm not touching the input. I want to... I need to get the steered wheels. I don't really need to get the steered wheels. I just have to get the... Okay. Jolt vehicle settings. Jolt vehicle settings. These... Do these currently admit that they're changed? Jolt vehicle settings emit changed. Cool. Alright. So whenever these are modified, that change signal is going to call out. My internet is stable today. Very nice. All right. Wheels. Settings. Okay, so I need to get the wheels. I need to... Okay, maybe I just need to, like, write down what I'm doing. All right, 1. Or what's my goal? Rotate the wheels back from the lateral slip calculation. They should turn back. They should turn to either 0 or 1, 0 or 90 degrees. If below 45, lateral, target 0. If equal or above, target 90. This should basically act as a resistance. I guess not as a resistance. Maybe I can make it like fully feedback. Should basically act as a resistance to user inputs if they are sliding too hard. They're sliding at an extreme angle. If not, the wheels sliding at extreme angle, or trying to reset against user inputs at low angle slides. Streamer can check which views are most points. I don't know. I mean, it must be possible because there's like bots that you can like check the leaderboard. I don't know if I can do that without a bot. What? I mean, yeah, switch to none. Hybrid GPU. What? Hybrid GPU switch and kept it at NVIDIA. Are you saying you weren't using your GPU? I don't know. Okay, so I'm not doing it with rotate back. So rotate the wheels back from lateral slip calculation. They should turn to either 0 or 90 degrees. If below 45, target 0. If equal or above, target 90. Basically act as resistance to user input. They are sliding at an extreme angle or trying to reset against user input at low angle slides. Okay, so first thing, I would just want a steer lateral average, which should be an angle which I can retrieve from I don't remember who I get this from. It's wheel info. Okay. What is this weird? Alright, so get wheel info. Hybrid mode on laptop when... It was going, yeah, okay. Wow. Alright. Start that at 0. I'm gonna do 4 wheel in controller. For wheel in controller. Get wheel info. Maybe one day I'll document this. So lateral slip. I believe lateral slip is the whole angle in radians. It's probably not. I can't remember what it is actually. I don't remember what it is. Am I blind? Physics. Jeez. Wheel.h. The lateral direction. So I'm not looking for that one actually. I'm looking for the angular difference. Awesome. In radians. Huge. Okay. The angular difference. So I guess I also have to know if this is a steered wheel. Okay, so it should come from max steer angle. Alright, but unfortunately, yeah, I do have to do this, so. Settings dot wheels I. Max steer angle is it's always positive. Good. I guess if it's just equal to 0, continue. Add 1 to I. I think I broke my friend. Red. Enough. Hey. Red. I don't know, man. You did your part. You told him he was stupid. That's the best you can do. Steer lateral average. So if we have that, now I know that this is a steered wheel. Should I... I don't need to think about performance right now. I need to stop with that. I need to stop with that. So steer lateral average. I'm adding lateral slip is an angle in radians. Do they mention the domain of that? Like if it's coming from this side, is it positive and then this side it's negative? Or is it just 0 and then no matter what it's positive, like that? The direction matters to me. Because if I have a wheel turned like this, if we're going forward, this is the angle, right? If we're going back, if somehow, I don't know how, we're sliding backwards, this is the angle. But in my mind, these would read as two different values, but I would hope one is positive and one is negative. So it'd be 0 positive in this direction, 0 negative in this direction, right? That's what I would want. So is that the case? Lateral slip, a cosine. So it can be negative. That immediately tells me it can be negative. But this is an absolute value. This is an absolute value. Yeah. I push him too bad. Nintendo's become part of his personality now. Okay. Hey, Dylan. Saw the video your cousin posted. Oh. Are you talking about me? Right, so this is always positive. I need this value to be negative. Can I know if it's negative? I guess I can. Yeah, I guess I know which direction it is by checking the forward angle of the wheel, or the forward direction of the wheel and the direction of motion of, but that doesn't work for moving platforms. Tire max impulse callback. This value isn't even used in that method. That's fine. That's a debug thing. What is this? Okay. Cool. All right. Nobody uses this value. That's awesome. So I can hijack it. I'm going to hijack it. Okay, so here's my thought process why I need to hijack this. Like I said, I could have used the forward direction of the wheel and the forward direction of the vehicle, dot them together, figure out which way the wheel is facing, and then I would know whether this slip is happening into the wheel or against the wheel or with the wheel, whatever, right? Because those matter. This is known because of contact point velocity. Because the floor could be something that is a dynamic object, which means the vehicle may not even be moving, but the tire is pushing something on the ground. Or, for example, the vehicle could be moving forward in world space, so as a positive, I'll just say as a positive x velocity, but it's on a platform that is moving very quickly backwards. Or sorry, that is moving very quickly forwards. So even though it has a positive x velocity, its like real velocity along the ground is in the negative direction. So that's why I want to hijack this, just to make this a positive value. Relative, okay, so here's the weird thing. What is going on? Here's the weird thing. Why is this not relative longitudinal velocity? Oh, if the velocity... I see it. If the velocity length is near 0, then we just say it's 0. Otherwise, we know this... Okay. There we go. And I'm just going to double check that a cosine has the right domain. Which should just be cosine inverse. Okay, cool. So domain is 1 to negative 1. So as long as this one can't be greater, relative velocity, contact longitudinal, I mean, they already did, so I don't need to worry about that. Okay, we're good. Radians 2 degrees, lateral slip angle. It is weirdly just written to put here, so I can absolutely value that though. And then M, lateral slip. It's not even used there in the default, that's debugging. Yeah, this is the only place it's used like that. Okay. Did I write it like this before? I feel like I did. Okay, let's get that built. I think it's lat slip. That's what I named it. Slip lat. And then I need a counter. Okay. Oh my. Alright, so now I should be getting positive and negative values. So if Steer count is greater than 0. Lateral average divided by steer count. And for now, I'm just going to print this value. Steer lateral average. All right, now I'm going to run it. Okay. So, all right. It's a very large value there. I'm trying to see if it can be negative. Can it really not be negative? When I was reversing, it was a very it was like very close to pi. Oh, you know what? I didn't even think about that. I mean, the output of this function is only positive. So I have an a cosine here, which gets me a value from 0 to pi. I didn't even think about that. Is the sine inverse? Yeah. So, do I just subtract? I don't think so, right? Because if we're at 0, this is 0. Dang. How do I know? I don't know. Because yeah, when I'm at 90 degrees, I get a value of. When I was reversing though, I was getting this value. So I was getting a value way down here. I guess that's just all I need then, isn't it? Is that all I need? No, it's... I'm trying to think. So if I think about visually, just an angle, okay, this is the way it's coming at me. 0 means it's coming forward, okay? We're in line. Yeah, how do I know which way is which? That's the thing. I don't know if 90 is this 90 or this 90. I need to know which one that is. So really, I would like this function to look like a full loop, right? I basically want this to be inverted over the x-axis as well. I need this output. To know. So how can I get that result? Wait, they absolute value this. They were absolute valuing this before. Which meant the output would basically bounce like this. Yeah. The output was bouncing like this. So pi over 2 would mean 90 degrees, which would make sense, right? Okay, so that probably means this has to be like that for this purpose. Can you believe you got banned for spamming AI generated? Dude, what? I don't think Discord bans for that. Okay, so I need I don't like it. How can I figure this out? There's a sign here that I'm missing. Somewhere I think there's like another absolute value happening that's correcting this. But I guess I don't know for sure. Bruh, what? I need the negative output badly. Need this fake number of mathematicians make up to solve mathematical problems? No, fortunately I don't need I here. There's no way I need that. Alright, let me just read through it. Body, get vehicle body, constraint, get point velocity, relative velocity, contact position. Contact position is what? I guess this is on the wheel, right? So it's contact position, get the body's velocity at that position. Minus contact point velocity. I guess that means the velocity of the contact thing. So, alright, so here's relative velocity. This should be a positive or negative value at this point. Cancel at relative velocity in the normal plane. So we remove the contact normal, which points up. So if the wheel falls down, the contact normal should point into the wheel up. So we dot the contact normal, which is a unit vector with the relative velocity, and we're subtracting relative velocity's contribution from there. Okay, so now relative velocity is basically been squashed, so it's on a flat plane. Relative longitudinal velocity is the relative velocity with the contact longitudinal. Okay. So this is now a vector that points forward or backwards only. That's relative longitudinal velocity. Then to get the opposite side of that, I have the relative velocity length. I essentially just say the lateral slip is the rest of that, right? That's what it should, this is what it should mean. So I take the absolute value of this. So this velocity, what? Is a float, right? Okay, so this is the path, yeah. So I already know the direction of it. The direction is encoded in the sign, so a positive value means I assume a positive value means the wheel is moving in the same direction as the ground that it's in contact with. And a negative value means the wheel is moving the opposite direction. So is that actually it then? If that's what I need to know, if the wheel is moving in the same direction as the ground, that lateral value, so I guess I need to get like a lateral velocity, a relative lateral velocity. A positive value means it's coming against the wheel, or sorry, it's coming from behind the wheel, I guess. Bro's delusional, coming up with that's actually it. And a positive value, yeah, positive value should be they're going the same direction, so you're basically coming backwards, really. Or I guess a positive value means the wheel is moving the same direction as the ground is moving. Or its contact velocity. Relative velocity. I like almost need to diagram this because I'm losing it. Ooh. Man, I lost it. I lost my train of thought there. Try it again. All right. So point velocity. All right, let me assume a static ground for a second. The point velocity is literally going to be the direction the vehicle is moving in, okay? So if we're going positive, it means we're moving this way, which means friction's traveling back at us, right? So we're moving in a positive direction on the ground. I'm going to say positive x. I think then it gets positive z. Sure. Positive z. Moving in a positive z. Let's say the tire is like at a 45-degree angle or whatever. If it's turned this way, we're going this direction. This means these should line up, which means I would get like a positive lateral slip. If the car was reversing and the wheels were turned this way, I would get a... Oh, I guess it's actually... Yeah, I would get a negative. This is in the negative z direction. Car's traveling backwards. I guess technically it's the other way around, but whatever. I'm going to say it's negative z is forwards, or negative z is backwards. This would make that vector be negative. So is it just like a wrap here? So because they do this absolute value thing, is this what that? No, because I need the output to be negative. The input is negative. When the input is, yeah, I am losing that information, right? So where did it get lost? Alright, you just gotta bear with me here. I'm really trying hard to visualize this. Alright. I'm drawing it. Apparently I can't. Apparently I can't figure it out. Oh, please. Okay. All right. So, relative velocity points this way. I'm going to say my tire is just in line. No. I'm going to say my tire is at this angle. Okay? Here's the tire. This means I have essentially, I guess, a longitudinal force that looks something like... I don't have any colors. That looks something like this. And I have a lateral that looks something like this. Okay, these two components added together would make this whole vector. All right? Now, what this means for me is that my... I would have a vector of this length in... let's go yellow here. Out of a vector at this length going this direction. And, okay, wait. Soft, no. What number am I looking for? I can get these two vectors just by decomposing this one. I get these two vectors. What would this value have? What would I like this value to have? Is that where I just like actually don't understand what I'm trying to make here? I feel like I literally just don't know. Yeah, what does this mean? This is the direction the wheel is moving, okay? There's relative velocity. I get the longitudinal velocity, and this is the lateral slip. If I turn left or right, this value is always positive. Right, but sometimes it points... What? How does this translate to... Am I dumb? What does this mean? This means I have a positive angle. Alright, I'm literally just going to copy this and flip it over. Alright. Whoops. Right? Okay. Delete that one. Duplicate, layer, horizontally. Okay. Rose learning physics. This is, I really am struggling with this one. So if I'm turning right, this would be the result of this. If I'm turning left, this would be the result of this. Now, the fact that this points left when I turn right matters, and the fact that this points right when I turn left matters. However, from the output, I think these two result in the same value. I basically just get this scalar value. I just get the length of this vector. I don't know, and they're both positive as well. And they're both positive. I need some way to know this direction. How would I know this direction? I guess in this case I would compare the forward... Oh, this is weird. Alright. Let me draw it one more time. I'm gonna draw the, if these wheels were actually going in the opposite direction, okay? I'm gonna copy these wheels. Erase these. Is it the angular velocity? The angular velocity has to tell it which way the wheel is rotating, right? So if the wheels are moving backwards like this, this first arrow was pretty bad. That's even worse. Can I just draw a straight line? There we go. So if the wheels are moving backwards like this, but they're spinning forwards, I guess in this case it would be spinning backwards if I was reversing, right? All right, let's assume first that the wheels are spinning forwards, so they're spinning this direction. Would be the longitudinal slip in this case? I guess in this case, okay, so I'm going to say that towards the tire is negative and away from the tire is positive. So I guess in this case, the tires have this kind of motion happening. This is so difficult to like. I'm gonna write an arrow here to specify which way the tires are actually rotating, which way they're actually applying force. So the tires are spinning this way, but I have this reverse thing because this is the... Actually, would it be? Because... Yeah. Yeah. Oh my god. I don't know. I don't know. I don't know. I can't even like diagram it. What is wrong with me? Alright, let me just run through it again. Angular velocity. Okay, so it can be positive or negative. The wheel's rotating this way, or it's rotating basically if it's rotating clockwise or counterclockwise. I'm assuming counterclockwise is probably the positive value, but whatever. Okay. Clockwise. I say clockwise or counterclockwise. It matters from the perspective you view it out to. Anyway, I happen to know the value is positive when I'm going forwards. Okay. So the value is positive. We compute this slip, which is basically computing angular velocity times the radius, which gets us essentially meters per second. Then we subtract our relative longitudinal velocity. So this will tell us the difference. And then we divide that by this relative longitudinal velocity denominator, which is the which can be positive or negative. How? How can it be positive or negative? It can be positive or negative, but then we take the absolute value of it. Okay. So basically this tells me, is the tire rotating with the ground or against the ground? But then we absolute value it, so it goes away. What I want to know is the angle. I basically want to know the angle between the forward vector of the tire and its actual direction of motion. That's what I want to know. I want to know that angle. Lateral slip angle literally computes that angle. However, it's only a positive value. Let me even get rid of this, as it's probably confusing. Could I, perhaps... So relative velocity length is always going to be positive. Maybe I would like to know... So we take the length of this, divide it by... Basically, I'm computing a dot product here. That's just effectively what I do. I'm computing a dot product here. And then I'm taking the A cosine. You do this with dot products to get an angle out of it in radians, as you can see. Of an input of -1 to 1, which is the domain of a dot product with a unit vector, if one of the vectors is a unit vector. Get an output between 0 and pi. So 0 and 180 degrees is the output. Right? So this is, I can think of this like it was a dot product. We take the relative longitudinal velocity absolute value. And I remember I drew like a shadow diagram, assuming the contact point of a tire is like, can be approximate to like a rectangular shape, because the tire is not going to like contact at a single point, it's going to contact at like with a surface area. Thinking about the shadow, when the angles are aligned, that shadow is really thin and narrow. When you're at like at 90 degrees, the shadow is very wide. It's much wider, so you have way more friction, which is why my friction curve is basically the top of a sine curve, which gets me really nice results. So the output of that is 0 to 90 degrees. It's 0 to pi. When we're at opposing angles, I guess I can think of it like that. Right, so if this is a dot product, the output is -1 to 1. But I have the added requirement that I need to know. Or is that it? Maybe I don't need to know that. If I'm reversing, let me maybe change this back. Let me look what these numbers are again. And I'm gonna multiply them by like pi or 180 over pi or something so I can get like the full angle. I think it may also be no, the angle is literally the degrees. This is pi though. I may have overthought this or overcomplicated it. Essentially, the result is if my angle is below 45, I'm returning to 0. And I think that means no matter which way I'm going, I'm returning to 0. If it's over, maybe I shouldn't say returning. If it's under 45, I'm targeting 0. I'm moving towards 0. If it's over 45, I'm targeting 1. I'm moving towards 1. But I guess I kind of know which way I should be targeting because I should just be reading in the current steer input. If my driver input is 0.5, I know that my 1 target should be 1. If my steer input is -0.5, I think that means my target input is -1. And I said 0.5 as if like that's like -0.5 is when we flip. No, it's just if the input was negative and I'm targeting 1, then I'm targeting -1. if the current input is negative. We should just go to like a flat area. So my input was negative at that point, so it should return to 0 because the value was low. Is that really all I needed then? So I don't need any of that other stuff? I do need this value. Okay. So I know this is going to be a value between 0 and pi, 0 and 90 degrees essentially. If I am over, or sorry, 0 and 180 degrees actually. Oh, no, never mind. Because of how the code is written, it's an absolute value, so it's going to be positive. And this is a length, so it's also positive. Between 0 and pi over 2, 90 degrees. So, and I guess I can kind of use, maybe, I don't know. How do I know how far to turn it back? All right, here's the thing. It needs to maintain its direction, right? It needs to maintain its direction. Which means... do really need to get like in the physics of it. Okay, so the inertia of the tire, maybe I can just discount that. Where does the... Okay, so I have 7 degrees, okay? Or I have 7 degrees, right? The tire is sitting at 7 degrees. How far do I need to turn it back to 0 this frame? What would that be based on? It would be based on the vehicle, right? The vehicle has to rotate basically into the tires. I guess perhaps due to friction, maybe the tires reset a little bit faster than normal. So the tires are turning this way, the car's this way. They kind of close the angle like that, right? The tire will move a little bit back on its own. but generally the car is what's turning into the tire. So does this mean I need to know... I guess I can ask if the wheel is in contact with the ground. That's probably what I should do, right? Has contact. So one wheel in contact is going to basically take all the force, right? I'll start this value at -1 just so I can increment it every time. I'm ignoring wheels that don't have contact. I'm ignoring wheels that are not driven, steered. And to say, okay, this one's going to have some slip to it. What's that angle? I guess I can also retrieve the friction value of that too. Can I, from the wheel alone, I don't know, this is weird. I'm not really sure how to keep going at this point. I'd like to know two things. I'd like to know the wheel like has two forces on it, right? It has essentially the spring, not the spring, the vehicle pushing it into the ground, and the ground pushing on it. Can I just simplify that to saying only the vehicle is pushing on the tire? And discount the any incoming force from the ground. Just say if all 1400 kilograms are on the tire, does that turn it back faster? Does it turn it back slower? Like what? I know the result should be that the tire tends to keep its angle. Maybe it comes back a little bit. I guess I thought that the slip... Okay, so I guess I thought the lateral slip is telling me the angle of the wheel against the ground. Which, I mean, it is, right? Maybe I just take this angle, multiply it by the friction, multiply that by What else do I get? I get like very little. I give myself little. I could give myself more. Alright, what else does the wheel give me? The total impulse applied along the sideways direction of the wheel. Lateral lambda. This is in newtons per second. I know that a newton is the force required to accelerate a kilogram at 1 meter per second. At a rate of 1 meter per second, I guess. Oh no, this is not newtons per second, this is newton seconds. So this is already like one step there. This is a timeless unit. Timeless? What? I don't know. It's independent of time. Or I say independent of time, it contains the time is factored in. Let me see if get lateral lambda is used anywhere. I don't know, maybe this helps. Calculate the target lean vector. This is in the direction of the total applied impulse by the ground on the wheels. Target lean is 0 for every wheel that has contact. Normalized or whirled up. Smooth the impulse. Move forward component. Normalize it. So do they get contact normal, contact lateral times lateral lambda? Should I look this up? Let me, I don't know, let me just see what happens. See if I can find anything. Why are my wheels phasing? Phase clan phasing into the ground. That's funny. You guys are weird. I don't even know. I literally just... Why am I lost? I want the wheels to turn... Oh, man. Turn with the vehicle. Turn with the vehicle. Turn with the vehicle. What does that mean? Turn with the vehicle. What if I just make them turn back their... angle amount. I guess I need to know. Oh, I need to know this actually. Slip lateral over the wheel setting max steer angle, right? This is in radians. Max steer angle I think is in degrees. That's radians. Cool. What's Jolt's licensing? I have no clue. Alright, let me try this. What do I get here? Okay. No thanks. What did I understand about this before? I think I said that I would just take in the vehicle's rotation. So do I just take the vehicle's rotation, how much it moved this last frame, and I subtract that from the steering? Is that what I do? I take each wheel's steer angle, this is what I do. The steer average will be the steer angle over its max steer angle. Rejected you harder than a blind girl? What? I'm trying to figure it out. I can't be distracted by probably silly people who use Godot for a week and they're making a tutorial for some reason. Dude, it's actually so bad right now. Tutorials on like anything computer science related are getting so bad. People who are really bad at it are just, they don't care either. They're literally like, all right, let's make a tutorial, install OBS, click record. All right, guys, that's all the planning they do. That's literally all the planning that they do. Your sister's going blind. I might have a chance with her. Not even that. We just need... People need to stop making tutorials when they don't know anything about it. They need to stop. Please. Have a script for your tutorial, okay? Quit winging it. Like, rehearse it at least 3 times before you hit record. Rehearse it literally, okay, record yourself rehearsing it so you can like watch it back and make sure you're not stupid, but it's so obvious when a tutorial is recorded and it's a one-shot recording, their first attempt, and they just went with it. AI probably makes it worse now because people are like, they just trust the AI to give them like a good script and they just go with that. So they're probably literally just straight up uploading AI hallucination tutorials. And they don't even know enough to know what's correct. If what they're saying is even correct. And then people who know even less than them are watching these tutorials and just like saying, thanks man, awesome tutorial, and he didn't learn anything. And then YouTube dislikes are hidden, so you have to install the extension to even know if the tutorial you're watching might be just garbage as well. If it's like a 10% ratio on that, then you know it's a bad tutorial. With that extension on, if it's like a 10% ratio, it's a bad tutorial. Yeah, then YouTube feeds those right back into the AI. Dallin, you sent me this one tutorial or something, or like a clip of this tutorial where the guy was using a sprite 3D for a crosshair. Unbelievable. Oh, my fell off. Dude, I just don't want to study physics for this. This is hard. Physics is too hard. If you don't have the right formula, it's wrong. If you don't implement the correct formula correctly, it's wrong. And you won't know why. You might not even notice that it's wrong. It might just seem okay, and then there's this one instance where if you reverse and you hold left and you're going over 20 miles an hour, your car fucking flies off into space because it just does a division by 0 that you weren't expecting. It's hard. I want to do this without getting anywhere close to physics. Let me just try it. Steer average comes in as a value from 0 to 1. So if the steer angle is 1, what am I trying to do? Well, what I'm trying to do is, from the lateral slip calculation, this should be it. This is what okay. I should focus on the car later. It needs to be perfect right now. If it's not perfect right now, then I fail. Here's the thing. There's so much like knowledge that I have to like keep in memory about how the car functions, all the classes I have, and all of that. That if I take a break from it and do something else and I come back to this, it's probably gonna take me literally a full day to be efficient in it. Maybe not even be efficient, like to get anything done. Because I need to remember how the system works. And right now, I know how it works. Meds now. Maybe I should think about how it does physically work, and I don't know, I think the shortcut of taking the vehicle's rotation the last frame, not even the last frame, this frame, I know it, right? This state contains its current rotation, how much is rotated. Reminds me of that amazing AI lore in Cyberpunk 2077 when an AI was tasked to make a car advertisement for a company online. Glitched and went up spamming and hacking every server to advertise that car. The internet is unusable, so people went to hosting their servers. I didn't even know that. From the anime, they said, I don't know anything about the game's lore, but I'm assuming the animes are really close to that. Didn't the anime mention that the internet that we use now becomes like just totally overridden with like viruses, essentially? Like you can't even connect to it because it's that bad. You're basically instantly hit with just like viruses. So if your system isn't secure at all, and it's like so much noise you can't even use it. The thing is, okay. Let me go with this and see how it works, all right? Let me make it happen. I take the current rotation of the vehicle. I get essentially the rotation on a single axis, the up axis. Not even that. I want the rotation along the world up axis. No, that's weird, because then if the car is rotated, that world up axis is super different, but it actually works because both tires are touching the ground and they're actually in line with this axis. So when the car is rotating like this, I want that car's up axis rotation. God, it's awful. This is awful. I think it will just come from the lateral friction. I think the lateral friction gives me things that I need. Okay. That's a lateral average. The lateral average will be, I'm just taking the wheel, slip lateral. just double check that I actually did this right. Of course you didn't. You can buy a car online in the game. How did I do this? Here's what I want to try. I want to go very fast down this road and then turn suddenly. Also, why does it say like 0.5 degrees? Am I really off? Did you wrote cuz? Why are you correcting? Why you? That's what you typed. What? Which word? I have the angle. I guess the angle tells me which way I'm going. Man, I don't know. Do I just need to have like some kind of resistance value? Like, if we're traveling 20 miles an hour... No, the tire just resets. The tire just resets with the turning of the vehicle. But this doesn't tell me the turning of the vehicle. Also, I can't even get it to like stay at... It's like 0.5. Why is it 0.5? Why is it 0.5? Is it the suspension pulling it in? I'm actually curious about what happened there. So I did go over 45, which means for these frames it would be pulling towards 1, the max rotation. And then I guess no matter what, at some point it would... I stayed at the max rotation the whole time. Then somewhere it would flip back, so it would start rotating this way. But I'm going at a really... I guess this angle is kind of encoded with the speed, right? If I'm at a low speed, even with a high angle, like I'm at max steer right now, but I have a 5 output. Okay. Just broke for some reason. So this would be slip lateral over the wheel, setting max steer angle. So it should be a value between 0 and 1, basically. So perhaps all I do is I just take this value and maybe I just say I guess I would take right minus, yeah, I'll do minus equals. Minus equals, I think this state gives me, it has to give me step, right? Yeah. I'll just see what this gives me. The sine of the current value. What happens? And I'm going to take the print off. Oh, the print is off. Okay. It's not returning. Okay. Why is it not returning? Oh, times the sine of right. Okay, so if this is 0, I understand. I get it. If s is equal to 0, or if s is equal to 0, then s will be equal to 1. Alright, this is what I was missing. Okay, so it's just not returning to 0 ever? Confused. Okay. Ah, okay, interesting. So it just starts turning, it turns left forever. Right, okay. But it should be turning back, because this would be right integrated subtracting. Oh, wait, no, I want the sign of. That's what my mistake was actually. This should just be the sign of right integrated. So does this mean it will be jittering left and right all the time? Okay, so it's returning to 0. Alright, so that seems right. But now it's not happening. Should it be multiplied by just the force of the friction? Maybe it should be. Because I can get that. Literally, why did that even happen? So I think I want the wheel setting, lateral friction, sample baked. Right? This. Hmm. Alright. So I don't think that was it. Should I just make this, like, return the wheel? Just give me the array of the wheels. Because then I can get all this stuff. Or maybe I pull out the functions that I want. So I specifically want to know if a wheel has contact. I want to know its lateral slip. Then I want to know its lambda. I think I want to read this just for a little bit. I don't think this actually, yeah, so this doesn't, does it? This is all engine stuff. So longitudinal lateral constraints, I get the wheels, max tire impulse. These are outputs. These are inputs. The suspension lambda. This multiplies it by that, right? It does. Okay, so maybe I would use that suspension thing then. Maybe that's where I get like how much weight the wheels how much weight is on the wheel. If there's a lot of weight, there's a lot of the friction, right? If there's no weight, there's nothing on it. Max lateral impulse, max lateral friction impulse, which is just lateral friction times suspension. So wheel solve lateral constraint parts. So lateral constraint part is not defined there. Declared. It defined, yeah. It is declared. Solve lateral, it uses lateral parts, solve velocity constraint. Using just the vehicle body and this stuff. So for this I need constraints, constraint part, axis constraint part, I believe is what these all are. I guess I can look. Lateral axis, right. So when it calls solve, what? Solve velocity constraint. Figures out what it's connected to, or I guess what type this one is. R body, which should just be dynamic. Body 2 could be any of these. So it'll just be templated solve velocity constraints. Those things. The axis. World space axis. Okay, yeah, just like the direction. Templated solve velocity constraints would do get total lambda, and constraint apply lambda, constraint get total lambda. change. Apply velocity step. Oh, add and subtract velocity. Okay. So we're subtracting on 1 and adding on 2. I guess that makes sense. But it would be static, right? Type 2 would be static. If type 1 is static, if neither one is static, type 1 is not static. Okay. I don't need to go on it. He's going on something. If type 1 is not static. JV. Get the velocities along this axis with R velocity. If we are not static, which would be true, we add, I guess, our angular velocity. Effective mass, what does that even mean? There should be no spring, I think. So it's just that multiplied by this amount is 0, I'm sure. So that gets me, this basically gets me newtons, right? With a velocity, which is meters per second. Just give me what does this result give me? They say it's Newton seconds, right? Lambda's Newton seconds. Then we get the change. We limit it. I'm actually not sure. What is this effective mass thing? Yeah, this is like newtons then, right? That seems strange. What is effective mass here? Yeah, where's it? How does he get the mass out of this? It has to be some value. It can't just be 0. Right? How does this work? How does it set that up? Where's vehicle constraint? The controller construct wheel. So stupid. New wheel. Okay. Constructs the wheels. On step. Because I guess the wheels have to have some effective mass, right? Because it's multiplied by that value. And that starts at 0. It starts at 0. Simply calculate constraint properties. Template to calculate inverse effective mass. Template to calculate inverse effective mass, which it's between two bodies, but like, what is the second body? That's what I don't get. Is the vehicle the effective mass? No. Is it the spring? Like, this is what I don't get. Where, how is this calculated? It's got to be calculated somewhere. But where? M lateral. Okay, well I know that it has to be called on the lateral part, right? M lateral part has to be done. Something has to happen with that. There's calculate constraint properties. Okay, so this is it. It calls calculate constraint properties. Between this body and the contact body. Okay. Calculate constraint properties. Effective mass. It's just passing the same parameters into this method. Calculate inverse effective mass. This one. Body 1 is dynamic, body 2 is static. Just trying to track down where the code goes. I forget what I'm doing it for. What am I doing this for? I was trying to figure out if I can find how they compute the force to apply and use that to apply back to the wheel. Templated calculate inverse effective mass. Type 1 is dynamic, type 2 is static. Type 1 is dynamic. The mass of the object plus this stuff. I really don't know what that means. M inverse R1 plus UX axis. What is all that? Store float 3, so these the result of this goes into here. But then for some reason I still use this one. Alright. I don't know. I just don't know. Alright. Rotation of the vehicle. Rotation of the vehicle. The wheel should keep its rotation. So I have its current. I'll use this. You know, maybe I can even use it all how it's written, okay? This is going to be like some angle in degrees. Or no, if I'm using friction, I have to multiply it by its like how fast it's moving, I guess. So do I need to give myself that value? Okay, if I give myself that value, that's probably going too far into physics, and I have to start accounting for masses and things like that if I do that. So I think I can probably just ignore this. I'll just ignore it. Okay, so I have a value between 0 and 1. Maybe I don't want that. Maybe I just want the angle again. Yeah, I think I just want the angle. Okay. Just the angle. So this should give me effectively the... Also, here's a weird thing. Why does it give me like a non-zero value? I'm always getting like a positive value. Right? It's either like 0 or 0.5. Oh no, it's red, the dick. Right, this is like always giving me 0.5. Yeah. So, why am I getting that? Wait, slip is... Wait, am I messing that up? Slip is in degrees, right? I call M lateral slip. This one. Or, yeah, this one. Okay, right, yeah, alright. This is in radians, okay. I need to figure out why I'm getting this as a positive value, because that doesn't make any sense to me. It should just be 0 all the time. One of these is 1 and the other one is 0. They're both like 0.5 and then it goes to 1 and 0. So confused. So they are sitting at, for some reason, like a half. Oh, is that? It's the toe, right. That's why they're sitting at a half degree. Yeah, so there's my issue. Do I need to... The front, these should be inverted then, right? Okay, right, they are inverted. Okay, so I would take this wheel setting toe. Is that what I do? Okay, for some reason it's still saying what? Oh. Do this, bring this back. It's still 0.5. Is it like... Just do absolute value. I really... Okay, the value is really close to 0, like all the time. 35. Cool. Alright. Okay, I fixed that. This is where a directional thing like really matters. Because I'm just getting a positive value for either one of these. Should I do toe times the position, the sign of the position X? Maybe that's a better way to do this. Oh yeah, and I was thinking like, okay, well what if the toe is like 5 degrees and it's in the middle of the vehicle? Then it would just be not subtracting the toe at all, which is what I would want. Like a motorcycle or something. I didn't even think about that. I mean, this whole thing really sucks, honestly. It does super suck. I was getting like negative... What? Getting like 10? 4 and 10 when I hit the brake. I guess if the value is already 0, then I don't have to move at all, right? Oh, this doesn't even handle like overshoot, actually. I'm so annoyed by everything. This is just such like a hacky thing. Okay, I'm just gonna keep going with it. So this is now a radians of, I guess, return value, right? And now I want to include I guess if this is a low value, what am I like doing with this? Because I would just take the vehicle's rotation and subtract that. The rotation of the vehicle along its up axis. Okay, I'm literally gonna start over. Yeah. Physics direct body state. I would like the angular velocity vector 3. The body's rotation velocity in radians per second. I guess I want... Let me just start printing the angular velocity. Show me the car's angular velocity. I expect I would see the Y component have something on it when I start turning. Okay, yeah, the Y is a very large value. Okay. Angular velocity in radians per second. Okay. I get the vehicle turn. In radians per second. So what I would like to do is take the right integrated value, and when I was turning left, this value was negative. I'm assuming if I turn right, the value is going to be positive. So I should... The wheels are negative. The right integrated is negative. This result will be positive. So I guess I just add this value to the wheel, right? In radians per second. So I guess I get the average steer angle. Average steered angle. I'll just compute it every time. It's not... whatever. Or maybe I just take the average steer relative to its max. And I'll take the difference between that. Or I guess I'll just take the average steer angle of all the wheels. So if the wheels are all at 40 degrees and the car is rotating 40 degrees per second, then I would take that difference. So I'd take 40 minus 40 degrees per second. I guess I would do a 40 over 40 degrees per second. So I'd say I need to be subtracting 1 every second. Yeah, I'd actually just do average steer. Yeah, I just want the steer angle. I need the controller info. Is it just called steer angle? Steer angle. I don't need to make sure that steer angle should be in radians, hopefully. Radians, cool. Pi to negative pi. Oh, that's interesting. Okay. If steer angle is not 0, or I guess I would say if steer angle is 0, continue. Okay. Steer count is greater than 0. We have steered wheels. I want to I guess I'll do right integrated. Clamp it to yeah, let me do this. Subtracting some value, the min of 0, or I guess I would say the smaller value, between something and absolute value of right integrated. Multiplied by, I guess, the sine of right integrated. And I guess I would do this. So if right integrated is not 0, doing all this stuff. So my thought was I'll subtract the difference, or I guess the division of I have to do this, otherwise it breaks and is stupid. So I was thinking it would be so this is a negative, I'm subtracting a negative, which is adding. If it's positive, I'm subtracting a positive. Subtracting. It will return to 0. So I think I said if I'm rotating slowly, I need to take off essentially, I guess, a relative value. So here's my thought. Is in radians per second. The steer angle is in radians. So I would do, I think it's vehicle turn divided by the average steer multiplied by the step. So if I'm turning, if the vehicle's rotating 40 degrees per second and the tires are at 40 degrees, I need to essentially have this come out to be 1. So in 1 second, I need to return to 0, is the idea, right? That would make this value get smaller, this value would also get smaller, they would basically track together until we reach 0. And I guess average steer, if steer count is greater than 0, and I guess I can do this, the larger value between average steer and, right, like that. The steer angle can be negative. So if steer angle is negative, it'll never turn that way. All right, so also I kind of forgot this part. Steer count, and then I need to make sure that it's close to 0. I guess I do sine of average steer times the max of the absolute value of average steer, and like that. I just divide it. So this will handle overshoots. So if we would flip the sign, if we would end up flipping the sign, which means we're subtracting a value larger than this value, this value would end up being too large. So we would take this value, which would basically be this times the sign. So we just return to 0. And I guess I can do if we end up close to 0, just set it to 0. So then this will stop. Is that it? Maybe that's it. Maybe that's it. And now I think I want the wheels to return actually a little, slightly faster, I think. Slightly faster than that. So how to make them return slightly faster? I guess I would multiply step by like some value greater than... like 1.1 then. Did I crack it? Did I crack the code? Okay, so... Sorry. Dog saw the dog before I did. Where's the print? I gotta get rid of this print. Oh, and then the acceleration is just totally busted right now too. So I need to fix that. I'm not... It's really... It's just always happening. I was like tapping left and I would instantly snap all the way to the left. Hey, Yulia. Should be on. Acceleration limit. 5. Acceleration is 4. I am resetting it though. I don't understand. Like the note's wrong right now. So why is it becoming such a large value? Did I miss it? No, you did not. Let me print... and... right integrated. I'm not actually sure what's going on there. You must not like shocking his dog. He said, check out what I learned. Alright, it did it. What happened there? Right integrated 5. So from a 0.1 input, we suddenly... Please. Oh no. Don't tell me Godot just freaked out and lagged. Well, Godot is freaking out and super laggy right now, so that's awesome. I love that. Literally for no reason. Okay, so I just know that from a small value, it went from 0.01 to 5.73 and then it started coming back down. So my right input is correct. My integrated thing just explodes. I'm not in the mood. I'm really not in the mood. I'm so mad. I'm stop. Please. My menthal's already crumpled. Okay. So right integrated went from 0 to an extreme value. How? I suppose he was never a good guy. Nope. There was a dog that walked by, and I should have seen it before he saw it, so I could prepare and like mute my mic or something. Or like, I don't remember, whatever. I did not. He saw it first. And then he barked really, really loudly. So what could make right integrated become an extremely large value? This is the only place where it can change. So we got here, and I basically did right integrated minus the smaller value. Oh, I see. I see what I did wrong. Okay. So vehicle, so these could be whatever sign. This could be positive or negative. It could be anything. So I'll just call it, I was gonna call it return. That's a keyword. I'm gonna sub. I can just go back. Oh yeah, I guess you're good. Recover will be this value. I guess if I'm multiplying it by the sign, then I can just do an absolute value of this, can't I? Yeah, I guess so. All right. I just write ABS there, actually. That was the solution. And that should fix it. Although I want to get rid of printing, because I'm sure that fixes it. So I'm not spamming the console. It's got to be logging, right? Or is it like moving the window while the game is active that like freaks out? I turn the flashlight on. Okay. And I'm off the map. Nope, I'm good. Oh, there we go. Go over this slowly. Oh my god. This is tough. This is tough. Driving this vehicle is kind of hard. Okay, so it seems like it's still doing it. The smaller value between... Yeah, I'm confused. Why is it exploding? It's definitely still exploding. Like, I'm seeing it snap to, like, 1 from, like, a small input. Okay. I need a smarter way to print this. If this value changes by like more than 0.2, then I'm going to print it. If the absolute difference between integrated and the new value and the old value is greater than, like, I'll even say 0.5. I feel like 0.5 is pretty much there. I'll print right last value %. I'll print with 6 decimals actually. New hypothetical. Man. I just want to be angry right now. Can I just be angry? Wow. Alright, that was a crazy thing. Alright, I spun it out. Into the ground and then, oh, okay, cool. It's snapping there, right? It absolutely is. I don't... Alright, just print it all the time. Print it all the time. I'm gonna move the vehicle over. So we're gonna barbershop. You did someone's hair yesterday, today you see them walking around with a hat. What? That is so stupid. No. People can wear hats. Alright, it's happening there. It's happening here. Wait, what's going on? Last value 1? Integrated 0.9. Last value 1? That doesn't make any sense. Alright, so I'm facing negative here. I start applying inputs. I just stop the game. Start applying inputs, returning to 0. Input's growing, it's growing, it's growing, it's growing. It's turning pretty fast, I think. Pics of the cosplay pics. Huh? I don't think so. 0.9, so it'll be positive. 0.1, 0.2. So is it just that the acceleration is allowed to get too high? Is that what's going on here? Because it's pulling back. Or trying to. Yeah, I guess the input acceleration is just way too high, isn't it? I guess this is tuned for this value to... Okay, so I guess it's not... Yeah. It's also actually a little laggy. Okay, let me change around how this works then. I'm assuming you're talking about pictures of other people. I don't want to see. I would like to make a game right now. So input okay, so steering. I think basically what I want to do is I want this to just be a value that kind of goes up to some acceleration, and that's what I'm applying. So maybe I have another toggle in here that's like integrated steering or something. If the vehicle is using steering, which expects small steer inputs, enable this. Which expects tools. Just leave it like that. Alright, so this will totally change how the input for steering works. So if drive steer enabled, if steer is triggered, I basically do right input, the target is the input at the target times. We'll move at the reset speed. I'll be right back. I'm back. All right, I've actually got it. I would like this to... What would I multiply this by, like... 1 plus... the friction or something? Wait, what do I do there? Let me look at... lateral... If I did 1 plus the friction, it would be like this. I guess I could multiply it by the friction so it turns back slower? No. Once it's a low value. Maybe I can do that. So I guess I could also compute the average, not just the average steer, but also the average the friction on it. Start at -1. If it is steered, no, I actually just realized something. It's not as simple as returning the tires. It's not like that. The tires should... The tires would not simply return to being in line with the vehicle. They would be in line with... Essentially, their friction should be pushing them some direction. So... below some angle. So if the car is like skidding like this, or the tire's skidding like this, the tire wants to turn that way, right? It wants to be in the same line that the vehicle is traveling in. Which is effectively just its lateral friction. So I'm getting back to physics, though. Basically, I want to turn the tires in the direction that will lower their friction. Or increase it, either way. Or not really increase it, but there's a tipping point where once it's so high, like near 90 degrees, the tire wants to be totally flat. If it's a little at a lower angle, then it would want to return to being straight. So that means when you turn left, they want to pull back against you to the right. So I guess I can compute that steer angle. I have the steer angle. If the lateral friction... I guess I would have the lateral slip angle. So I know the angle and I know... Or no, I just have the angle. The steering angle and the slip angle. So if the slip angle is 1 degree, the tire wants to move towards 1 degree, right? Okay, I'm going to save this because I think this is at a pretty good point right here. I think this is at a pretty good point. So, whoops, deleted too much there. So this is all going to be, well, I guess I'll just document it. Actually, maybe I'll just make it a function. Update right 1. Okay, so here's my first solution, which is kind of alright, I guess. It does achieve what I wanted it to. But I don't think it's quite there. So, my second attempt... So, I'm not even considering that. What I'm really doing is I'm kind of adding up a difference of steer angles. Probably just copy all this. I need the controller. I want the tire's steer angle to be changed by its slip angle. So if there's really low slip, they're not going to move so much. If there's really high slip, they're going to move a lot. Okay, that's my idea. So I guess what I will be taking is a steer difference. So for each wheel, I'm taking its steer angle, and I think this is where I would multiply by friction. So at the higher angles, it wants to return faster. But I guess I might even like limit that to the vehicle's rotation, like this. I would limit it to this. I don't know, I can add that in if I want it. So like I said, the tires basically want to, below 45 degrees, they want to minimize their friction. Above 45 degrees, they want to maximize the friction. So if the steer angle is, I won't worry about that. I'm just going to make it return to 0 no matter what. Or not return to 0, but minimize their friction. So I would get the steer angle and the slip angle. I guess the question is which way is which, right? The steer angle can be positive or negative. So would it just be taking the steer? Because if the steer angle is negative, okay. Let's just say I'm turning this way, and the tires are coming this way. The tires want to face that direction, right? So the vehicle could either be oriented like this, so the steer angle is 0, so I need to subtract from the steer angle, or the vehicle could be oriented like this. So again, I would need to subtract. The vehicle, I guess, could be oriented like this, which would mean I need to, I guess, yeah, that's always a subtract, isn't it? It's always a subtract in that case. Yeah, it doesn't matter what the current angle is, I'd be trying to subtract it. Which means that angle, I need to know if it's... Yeah, I need to know if it's... I need to know which direction is minimizing the friction, I guess. But I don't know which way minimizes friction. Would it just be... the direction that minimizes friction? Does the wheel... do I get some... I mean, I guess I get some. I get the contact lateral. It's a vector 3. I don't really want that, though. I want lateral lambda. Let me see if I can get the lateral lambda. What does it look like? I guess I'll get both of these. I just hope this is a positive or negative value. If it's positive or negative, then I know for sure which direction should be minimizing friction. Which rotation direction should be minimizing the friction. Let me just comment that all out. Now I'm going to use 1 and 1. I'm just going to print Cool. Okay. Looks like it is how I expected. It's generally positive or negative. Awesome. No way we're doing this again. Okay, good. It didn't. It kind of glitched out there. It glitched out a little bit. Can you stop doing that? Annoying. All right. Okay. So if we are, I think it was like when I was trying left, it was negative, and right, it was positive. So when it's positive, I want to subtract. When it's negative, I want to add. Right? I think that's what was happening. Alright, let me run it again so I can remember, because I forgot. Be serious. No lambda lat. Well, what did I call it? Seriously? Missing the left, negative, right, positive. Okay. That's all I needed to see. Left, negative, right, positive. It's in the same direction as the steering. Okay. Positive for right, negative for left. So I'm just literally subtracting the value, I guess. So I think what I do is I take that, or I take that lambda, multiply by the friction. I'm not even sure that's how it works. I mean, they take the suspension and multiply by the friction. So I guess that's the same thing. So steer difference is, I guess what I want to do is I need to compute this such that each wheel is applying a value of 0 to 1 based on what it wants to do. And then I average those. So for each wheel that's in contact with the ground, okay, so first of all, they have to be steered. No, they don't have to be steered. That I don't even care about that. They need to be steerable. That's what they need. And then they need to be in contact with the ground. If not, W as contact. Continue. Wheel settings have to be W settings, wheels, I. Wheels are wheel base settings. They have to be steerable. Okay, so they are in contact with the ground and they can be steered. All right. What were the values I was getting? Alright, let me start with like the first time I started steering. I hit left and I got like negative, I got 40 and negative 41. And they were all negative. I think that's partly because of the toe effect, which makes sense. This slight turn should basically kind of cancel out, I guess. It's a little more positive, I think. Let's see if it ever flips to be more negative. Okay, so here's more negative. Here it's way more negative. Yeah, way more negative. Still negative, still negative, and that's super negative at that point. Okay. And then I guess I'm probably bouncing or something from the suspension because this tire has like nothing, and then it goes back. Yeah. Right. So that means the wheels want to... They basically want to subtract this value from their steer angle. And the scale of that number is how much it wants to do that. So I'll just see how does inertia fit into that? Because if I guess if I have like a 2, I don't know. Maybe I would take this over its suspension. So if it has... No. If it's not in okay, so here's what I'm trying to figure out. I basically think I want to divide this by its like suspension impact or something. So if it's in full contact with the ground, we can do like 1 rotation per second or something. If it's really not in contact with the ground, the value is decreased. GOG added Stalker Gamma mod pack. I don't know what that means. Which GOG? And what's a Gamma mod pack? Like, I don't know what that means. Those are just words. I guess I could use the inertia of the vehicle. Maybe I divide it by the inertia of the vehicle. I do have it. I can multiply it by the inverse. The inverse inertia. Oh my gosh. On the y-axis. Maybe that's what I do. Let me just see if I can make them always face the direction of the vehicle travel. Oh, okay. Cool. I don't know. I'm physics or weird. I'm not really sure. I would literally just be guessing. But like if I guess wrong or if it's just not like very physically accurate, then it's I need some basic value and then I can scale it by something. Hey, laugh on store like your true not worth in game. Huh? See leaderboarding him showing you other Stalk MCs being better than you at everything. Yeah. Interesting. I'm so lost right now, man. I mean, I guess these are kind of canceling out, right? But sometimes they get really large. And also, I don't know. Let's bring it back. I need to leave these print statements here because I keep putting them back. Stop deleting the print statements. Okay. These are kind of balanced, and they're both negative. And then I think I probably start turning the other way, or I'm just like, this is 0. I guess it doesn't have contact with the ground. This is wheel 1, so this wheel's like, yeah, it's like off the ground. And yeah, it like, you know, it starts taking on all the force, I guess. And then at some point, I guess we probably land. I guess we're both wheels probably connected at this point. That one's off the ground again. When do I start turning back? I guess I'm probably turning back throughout all of this. I don't know. Because suddenly they all just go positive. In one frame, it goes from this negative value to this positive value. That's kind of crazy. What? How does that work? Negative, 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 negative. Positive, negative, positive, negative, positive, yeah, what? This just like suddenly flips. What am I like doing some weird inputs or something? How's that happening? I don't understand. How in one physics frame it goes from... it flips. How does it flip? They both flip. It's like... what do I not understand there? It's like they're teleporting. Why is it not continuous? I'm so confused. Is it just that... is it actually just because the rotation is just that fast? I'm gonna ignore it. I'm gonna ignore it for now. I'm gonna ignore it for now. That's really weird. Whoops. Huh. All right. Yeah, I think I said my target is just to make them face the direction that minimizes their friction, but I guess the weird thing is, how do I know what that difference in angle is? Oh no, the thing is just telling me which way it should be turning. The slip angle tells me where it would like to face, right? That one is just telling me kind of the direction that it needs to turn in. And I guess also, I have power, or like amount of force to turn it with. So if it's a really high value, it wants to really, you know, turn very far. I just don't know the scale of that. So I said like 500 or something when I ran into the wall. Or not ran into the wall, went over the curb. It was really high. I'm so bad at this. Okay, so we can steer. I have a steer angle and a difference. I'm calculating an average steer difference. That's what I'm doing. The average steer difference, we'll be adding the wheel slip lateral, right? This is an angle in radians. Okay. Now I also need to say this should be multiplied by the sine. For now, all I know is it's the sine. The sine of the sine of the lambda. Okay. If steer count is greater than 0, steer diff divided by steer count. And then this can be, I don't really have this. And I'm not really doing it in this way. Okay, so I want right integrated to face to go in this direction. Okay. So the steer difference is divided by this. I don't think I need to do that. Just subtract the average steer difference. So I'm turning left. I have a negative value, so I'm subtracting a negative from a negative. So it should get me close to 0. And then ideally become 0. Let me see what happens. Okay. Here. Interesting. How about they face straight? And they really want to correct back to center. And I can kind of recover. Oh gosh, all right. Okay, so that was something. So it seems like I may also, oh, I remember what I did. So slip lateral needs to also I need to subtract the the toe times the sine of position X. Yeah, I'm totally trying to type break there. Stupid. Makes no sense why it does that. It's like, oh, you... Like, I literally do this. Backspace. Oh, you want to write... Actually, I guess I would do... Maybe like this. Backspace. And then it was like hitting enter, and it was like entering break. I'm not even sure how it does that. How does it do that? There's a new trailer for PUBG. Never mind, there is no trailer. Okay. Alright, so there's still like weird and want to turn very far that direction. I'm not sure why. So what's going on there then? I thought I accounted for that. And they just turn that way. And they get stuck over there. So what happened? I land. Should basically become 0. Basically 0. Now it's not quite 0. I think I know why. Because I think eventually it gets to a point where like one tire for some reason is really close to 0 and the other tire is like really positive for some reason. Multiplied by that sine. Which that's the only way it can become negative. So first two are zeros. And then it's a little... 0 has a larger value, which means we want to turn left, right? I want to turn in the direction of this tire, I guess. And they get negative, and then they just kind of keep becoming negative. It's weird, because they should kind of like be counteracting each other. When I drive straight, then they're... Maybe I need to multiply it by its longitudinal lambda or something. Or maybe I said the longitudinal needs to be greater than some value. I guess let me try that. Wait, isn't this supposed to be... Oh no, this is fine. Those are fine. I can grab those. Or it's like too small, right? I mean, let me just print it out, I guess. Okay. That would happen again. It took it a long time to close. So the first one was longitudinal, the second was lateral. So yeah, I feel like longitudinal needs to be pretty high. So yeah, this is like building up, isn't it? The front two tires are like trying to... The left tire has a smaller one than the right one, which would mean this value turns out to be positive, which means I would want to go in the positive direction. I want to turn right. It seems like maybe it feeds back somehow, because that's exactly what I have it written to do. Oh no, it subtracts it, which means if this is positive, it'll be subtracting a positive value, so it's trying to go back to center. So why is it not going back to center? Like, this value is always greater. It's like constantly trying to go back to center. This value is always a greater absolute value. I guess then sometimes it's like negative. So it wants to turn that way. Then it's positive. Oh, these are back tires. I'm being stupid. Right there. Let me look at this again. That's a crazy question, Danilin. It seems like when I try turning it backwards... So this is... Looking at zeros first. This is a negative set, 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 positive set, positive set, positive set. But the longitudinal is really low all the time, right? So... Oh, and then I meant to be driving it. Why is the lateral so high? The longitudinal is like really small, and the lateral is really high. Why? Why is it like that? I was gonna say like, okay, longitudinal needs to be like a big value, but then it's like barely a large value. I guess it became a large value here for like a second. Those are large values. But they were just like only on one tire or something. I guess I was holding the brake there actually. Never mind. Let me redo that and not hold the brake and just start accelerating after it settles. Yeah, this is where I'm accelerating. This is weird though, because this means like the tires are pushing... These values seem so small on the left, and these ones are really high on the right. Like 40 times more. Like, how is the car not like... And being a value of like 2 was enough to accelerate the vehicle. Oh, maybe it's because I'm only looking at the rear tires then, isn't it? You know what, maybe I just multiply it by this value. Maybe I just try to multiply by that value. The absolute value of this. Yeah, maybe that's what I do. I just multiply by the absolute value of that. I think it does become unstable though, so... Maybe I do that. Let me just double check that NH of X is that. That's what I wanted to see. Cool. Are the tires freaking out? They're like not even moving. Okay, holding brake like obliterates them. It overcorrects like pretty hard. Hmm. Hmm. Alright, so yeah, I guess there has to be some kind of resistance to that, right? So it would be... I don't know, maybe I'll just say like, take a quarter of this value. And I can probably turn off this printing. Yeah, so holding the brake like does crazy things to them. Alright, that honestly sucks. After trying it a few times now, that I actually just think that straight up sucks. That's no good. So, I think this one's probably what I want then. And maybe this should be... like 9% or something. 90% of it. So it's not fully spinning straight back, it's only going some of the way there. And it doesn't have this weird instability stuff. Alright, so that just kind of like failed there. I don't know, it's like they both are not very good. This one is kind of too powerful, I think. Maybe I just take this multiplication out. And maybe I do like 7%, 70%. So did I not fix like the thing where it just like teleports super fast? Alright. So I think maybe what I need is I need to have... I guess if the average steer is close to 0, this becomes a really large value, but then it's limited. It can't subtract more than this. So where is it getting like a huge value from? Maybe I just need to work on this. So if the player has this integrated thing turned on, the acceleration now basically becomes the value. So I guess I'll still do the reset speed. Or no. Also, there should be sign of that. I don't know why it's not like that. And up here should be the same thing. Should be the sign. Alright, so if steer is triggered, here's my target. And I'm just going to start riding it my own way. So if we are using this, I think basically as long as I'm applying the input, I want to increase. Yeah, I want to increase this acceleration value. So I want to say this vehicle right input speed. Add, or just add a steer acceleration times delta. This would actually be this. The smaller value between this one and yeah, I guess in this case I would use the acceleration limit, right? Okay, so we're just adding it, and then let me just divide that by 10. I feel like that is probably better. Divide that value by 10. And then steer integrated, that literally just is what I'm doing. If not, I have some special things. So I am saying if drive. This is different. If we are integrating, I am. Should bring that deleted line back. Decay it to 0. vehicle right input speed is not equal to 0. I want to decay it like this. This value minus the acceleration. I guess 0, 3. I'll say 0, 5. Over 10. Let me make this a constant up here. Rate of input, acceleration, decay. I guess I know this is just 0 times 0.1. We are integrated. Decay this slowly. Maybe I don't even... No, I should leave it like that. And then... Honestly, maybe I just do this. If I'm doing this, then I want... this to happen. So these lines can kind of stay the same. Not kind of, they will stay the same. Well, they'll still be indented, so... I guess maybe not. Just be otherwise. If string is not triggered, and I guess this is actually pretty simple. So you can just come back here. Steer is not triggered, I will decay it. And then at the end, vehicle right input is vehicle right input speed. Let's see if this is a little bit better. Interesting. Okay, I can't turn back the other direction. It's just... okay. Oh, I get it. No, I get it. Right, input speed plus what? Okay, no, I get it. This is 0. Or I guess it's actually... Right, okay. So it would be the input speed here, value x is 1D. I guess it would actually be the sine. Well, yeah, I mean, that's the same thing. So the acceleration is insane. It is insane. This will also be 0.1 times that. Oh, what? This is 4. I need steer. Oh, yeah, it should be like that. So it'll be 0.4 acceleration. That's still way too high. That's way too high. Why is it so extreme? Dividing by 10, should I divide it by like 100? The other one works so much better. What's with the other one? I guess I also... Oh, I should also be multiplying it by delta, shouldn't I? Because this is an acceleration, and this is a rate per second. And now I can't turn the tires at all. Okay. What's going on? Why can't I turn this at all? Wow. What? What? How is that happening? Write input to add the input speed. Do I need to take off the acceleration limit, I guess? Maybe that's just, that shouldn't have that like that. I can't turn. I straight up actually can't turn. That's crazy. I can't turn at all. So I think the only difference is that instead of adding this, I need to be doing this, multiplying by delta, and then calling that, and this is my right input. Like, this should be the same thing. This should be the same result. Integrated steer is enabled if steer is triggered. Vehicle right input is the value times the input speed times delta. And this is how I add it. Input speed, we're increasing the input speed. Right input speed. And I just added that value. Then it goes steer with that value. If I'm not pressing the button, I decay this speed. Just print it, I guess. It has to be like a value that's really tiny and just never growing. Okay. What? I'm so confused. What is like going on? Why is this so weird? Oh, what? This is for... Jeez. Yeah, that's still not quite right, though. What if I were to divide this by delta? To allow it to grow larger than that. It's just getting faster and faster. Alright, so the acceleration limit is just kind of busted. But I don't know, let me look at it again, I guess. Alright, so I hit like 0.9 really quickly. Or like 0909. 00909. So steer acceleration limit. It limits it to 1.5. Which I guess is actually meant to be like a limit before time is applied. Which is exactly what this is. This is a limit before time is applied. So 1 means... 1.5 means that in a second, less than a second, I would be applying an input of 1 over the course of a second. It would take me a second to reach it would take me less than a second to reach an input of 1, is what this should mean. So I'm doing something wrong somewhere. What is this like fluctuating number thing? I'm so confused by this. Now it's like correct. Is that correct? Like, I don't... 1, 2, 3... I feel like it's 1, 2, 3... It's definitely taking longer than 2 seconds. So why? Why is it definitely taking longer than 2 seconds to do this? I guess I'm doing the math. Is... Yeah, that ain't right. This just means that input speed should be such that over the course of a second, this input should sum up to a value. Over the course of less than a second, this input should sum up to a value of 1 in less than a second. So what's my mistake? Why is it not like that? I have to add the acceleration times the delta, which is correct. But then the steer limit, acceleration limit is 1.5. So 1 times 1.5 Yeah, so it should be reaching 0.0234. So what's wrong here? What is wrong here? Is this like a weird value? No, this is enabled there. World. Huh? Is it doing it twice? Is it decaying it a lot? If drive steer integrated, otherwise, if steer triggered, do this, otherwise do this. What? Small value between this one plus this. So we keep adding up until we reach this value. Huh? What's going on there? And why is it fluctuating? This is so confusing to me. Something else must be messing with this. Like, this isn't supposed to fluctuate like that. Steer is always triggered. It's constantly adding. Oh, wait. No, I get it. No, I get it. No, I don't get it. Because we're just adding to the value. As long as the button is held, we're adding, this value is increasing. That's what's happening. So no, I don't get it, actually. Okay, let me do a find for this. Maybe somewhere else is modifying this value. That shouldn't be modifying it. No, it's only modified here. I get it. What? Why is there a 1.5? -1. This value. Okay, so the second value should be increasing after the -1 should be increasing to 1.5, right? And it is. It gets there, right? It gets to 1.5. Yeah. So -1 times 1.5 times delta. Oh. No, I get it. These are... This is a different delta here, isn't it? Steers integrate, I'm using a different one. It's going to be physics delta. How do I get the... Hit physics, process delta time. Yeah, there we go. Okay. So this value can increase according to true time passage. It's probably better. But when I'm setting this one, this needs to be physics delta. Right? Yeah. Because this is received on physics ticks. Or perhaps if I have, I guess I could just say if I have integrated, I need to multiply the input by the delta. Maybe that would be better. Plus right times delta, yeah. I think this is what I should do, right? That's just what I should do. So then I don't do multiplication there. It just comes out correct. Okay, that's it. That's what I needed to do. Still pretty bad. Honestly, it's and then I can't apply enough force to actually turn the car either. I can't overcome that. Okay. Maybe I'll move it up to 2. Maybe I actually double the limit. I just double it here. I'll multiply by 4. That's still like really slow. That's kind of crazy. I guess actually if I'm just going to multiply by 4 all across the board, then I would just multiply by 4 here. And like I just really can't apply enough input. And then I'm slow enough that I can actually overcome that. Weird, what is happening? Huh. So interesting. It's getting like reduced too quickly. I even already have it at like 0.7, and that's still fast enough that it's like clipping itself back to 0 too quickly. Let me do, instead of 0 procs, let me do if it's less than like, if it's less than this value. Or I guess if the absolute value is less than this value. Maybe that's a problem? I can't get it to turn at high speeds just because it's... Wow, okay. What if I made that, like, do nothing? Does this give me control back? I mean, it's definitely too little. I don't know. Maybe I just need to make it times 8? Times 10? Just go all the way to 10. Why does it feel like this is changing nothing? 100. It's changing nothing. Huh? All right, because it's clamped. Because it's clamped to 1. Wow. Okay. Okay, so if enable integrated steering, I do one thing, otherwise I do this. I just said it. All right, that's where the issue's been. All right, so back to times 4. That's why. That's why I couldn't get any input in there. And now that's just too much. Too much. Okay, take off the times 4 then. Okay, so I still can't overpower it. What is going on? Too much at not enough to turn it at all at 1, too much turning at 2. What's going on there? Why does it suck? Because yeah, I get 1.5 as the result here. I don't know, do I just double the limit then? I just double the limit? No, this is weird. This is so weird. All right, I've got it. Right integrated. I would... Yeah, just do this. Don't multiply by step. No, wait, I think basically what I want to do is I want to this is stupid. This is just really dumb. How do I want to turn the tires here? Basically what I'm doing here is I'm accumulating value over time. Which maybe I shouldn't be doing that. I want to take my value that I give it and add right integrated. That's what I want to happen. I want it to be I'm not including right at all, right? If right integrated is not equal to 0, which it will never be equal to 0. All right, you know what? I think I gotta call it there. I'm thinking of a third way to do this now. Like, I don't like that. I don't want to do a third way. I'll explain it anyway. So essentially it'd be a combination of these two. Except I would use this one so the wheels want to turn back. But this is a small force that applies. That applies to your input after the fact. So I would compute some change to your input through that. And then down here, I read in your input, and I would be like, right, plus this force, plus whatever like I want to happen, right? So, and then integrated, and then I have a different idea for the steering. Essentially, when I use integrated steering, if I'm applying input, I basically have a curve, I guess. So as I'm holding down the button, I have this like curve. So if I'm holding it for a short time, we target a short angle. If I'm holding it for a long time, we target, you know, closer and closer to 1, basically. The longer I hold it. I mean, a linear curve could work, but I think it'd be like, probably like this curve. I guess where x is greater than 0. Right. So essentially it will, you know, it gets really close to 1, but you have to hold it for a long time. It starts off linear and then it kind of tapers off as you hold the button longer. Essentially that kind of curve. Except maybe a little more... What am I looking for? Like 2x? So maybe more like this. Stronger curve. What about EX? Right? And then when I release the input, we drop back to 0 immediately. But then when I press the input, I basically check where I'm at on the curve, and I start moving from there. I read in whatever I check whatever my right input is, and I start from there. Say if I'm holding left, okay, drop like this. If I'm holding right, go like this. BEX is too extreme. Maybe even just like a sine. I don't know, maybe the tan is right. So if I start pressing left, actually, yeah, this probably should be like a little extreme. I don't know. So if I'm at a low angle, I'd like take one step left, and because of the shape of this curve, when I'm at a low angle, I mean, I think it should be pretty linear when you're at low angles. Then if I'm at a high angle, and if I'm like pressing left here, like this is my input, it's slowly growing. I don't know, if I think about this in seconds, it feels like it's probably not fast enough. Maybe something like this. So for like 1 second, my input would be reading 8, and I release, I start... I guess I don't step back. I just set to 0. So once I start pressing the input, I check what my current tires are at, and I start from there, and I start going left to right, depending on what I'm pressing. And then, like I said, back to the vehicle, it's just taking... If I'm applying inputs... I don't know, this is the weird thing, right? Because it should be an offset to your input. I guess if there is no input, then... Or maybe right integrated is just always set to your input value. It just is your input value, and then we add or subtract that force from it. So my input... So with the integrated thing, my input is always growing. And then I would just subtract whatever force I'm applying to that to counteract it. So yeah, probably 10 inches is pretty good there. as like a natural curve. So yeah, I would basically take... Yeah, this is the thing that gets weird, right? I guess right integrated computes the force that I want to apply to it. So I guess it would be like right plus equals right integrated is what I would do there. And then every step I'm computing what should the force be. And I can just clamp it on one line. I did say it was done, but I don't know. That's an input thing. I don't know. I gotta think about this more, I think. I do. I know that I have to. So I'm gonna end it there for today. Thanks for watching. Thanks for hanging out. I'll be back tomorrow. Hopefully for a longer time. Goodbye.